Welcome. Didn't see you there. This is my home. And it's a lovely Saturday morning, so I'm just going to record a video for you guys about polynomial and rational functions. It's not about rational functions. This is the unit about polynomial and rational functions. And this is our kickoff video about that, which is all about polynomials. So what are polynomials, and what are some of the terms that you might need to know when talking about polynomials and so forth. Okay, so grab a cup of coffee and let's dive right in. That's good. All right. So what is a polynomial? So yeah, I have a graph of just a polynomial x to the fifth minus 3x cubed plus x over there on the side. You can kind of see it's got this smooth, wavy behavior, and that's true for all polynomials. They're all going to be nice and smooth. No like jumps or breaks in the graph, and continuous throughout all of the numbers that you would want to plug in. But what do they look like? Well, they're going to be functions, and the functions all are going to have this kind of general form, where you've got different coefficients. That's what these a values are. These numbers a sub n minus 1, and so forth. And then multiplying different powers of x. And all the powers of x are positive or zero integers. And those numbers in front, multiplying each of those powers of x, are real numbers. Okay, and so this is kind of a weird notation. We've maybe not seen this before, where we're writing out this ellipses, this dot dot dot. This means that we've got, you can have many terms for a polynomial. It doesn't have to have just 3 or 2 or 5. Each of these, I'll just highlight this. Each of these guys, this is called a term. Boom. So that's a term. Okay. So each of those terms is, you can have as many as you want, up to some finite number. So n, is kind of like the upper. That's the biggest power is what we're gonna get. And the a subs, these little a subs on the next slide, we're gonna refer to those as coefficients. Okay, so some terms. So there's our polynomial a sub n to the x to the times x to the n plus a sub n minus 1 times x to the n minus 1, and so forth. So some terms we've got are like the degree. So you would say the degree of a polynomial, and it's usually given this symbol deg, D-E-G, of p. So you can think of it like a function. You give it a function, a polynomial function, and deg returns the highest power, whatever that is. So in our general case, our highest power is n. That's what's up here. And so that would be the highest power of x. That's the degree of the polynomial. And then each of those numbers in front, multiplying each power of x, these are referred to as coefficients. So coefficients are all of those real numbers, a0, a1, a2, a3, etc., and so forth up to an. And then the top one, the a sub n1, that's given a special term. It's called the leading coefficient. It's the coefficient for the highest term, so the one with the biggest power of x. And it's going to have significance when we're interested in end behavior later on. Like, what do the polynomials do when you plug in very large values of x, and are they going to go to infinity or negative infinity, and so forth. Okay, so here's an example polynomial: 2x cubed minus x squared plus 1. And the degree of this polynomial is, I'll just highlight, say like I'm using red for degree. The degree is the highest power of x, so that'd be 3. And the leading coefficient, you can highlight that maybe in green. Leading coefficient, that's 2 in this case. The coefficient is whatever's multiplying highest power of x, so that's 2. Boom. Okay, So those are some simple terms. We've got degree, coefficients are the numbers multiplying, and the leading coefficient's the biggest one. And we'll just add one more term in here to this slide that I forgot to mention, but that's that this last term, this is called the constant term. Constant. And so this is the one that has no power of x, and so it has no x, and it will always be whatever value it is. Okay, so that brings us to talking about even and odd polynomials. So an even polynomial is a polynomial whose degree is even. Remember that the degree is going to be some number 0, 1, 2, 3, 4, 5. It's going to be a positive or 0 integer. And so our polynomials can either be even degree, 0, 2, 4, 6 is the highest power, or it can be an odd degree. And then 1, 3, 5, 7, 9, and so forth. And all polynomials, no matter whether they're even or odd, are going to have a domain, unless you restrict it, unless you make it smaller, of negative infinity to infinity. So all polynomials will be able to range over all the real numbers, or not range, excuse me. The domain will go over all of the real numbers. And the reason for that is because you'll always be able to since you're just multiplying a number by itself so many times when you raise it to the 4th power, and you're adding and subtracting these numbers, there's no bad numbers that you can plug in. So polynomials are very nice functions, and they're very well behaved. There's no bad inputs. There's no weird jumps. It's nice and smooth, and you can plug in any number you want to. When the degree of the polynomial is odd, then you're going to find the range will be all real numbers. You'll be able to get any answer out from an odd degree polynomial. It's not necessarily 1-to-1 though, because you can have odd degree polynomials, and we'll see this later. You can have odd degree polynomials that do something like this, up and down, and then zooms off to infinity, and either direction. But it's not 1-to-1 right here because it would fail that horizontal line test. So not most polynomials, I'll say this, are not 1-to-1. Only a small chunk of polynomials will be 1-to-1. And in fact, if the degree is even, it's for sure not 1-to-1, because you're going to have this kind of U-type shape where it blows up on either side, and so that's going to fail the horizontal line test. When the degree of the polynomial is even, then the range is a lot harder to find. We found when we were looking at quadratics which are even degree polynomials, because x squared plus ax squared plus bx plus c, that's a polynomial with degree 2, that to find the range of that was actually non-trivial. Like, you had to go about finding the vertex either by completing the square or some other means, and then once you had vertex in hand, you were able to find the range of it. But unless you had the vertex, you couldn't find the range of a quadratic. Cubic functions, 5th degree functions, and so forth, those you'll be able to say they go through all real numbers. But those even degree polynomials, they're going to have some lowest value or some highest value, and it's going to, you'll have to like graph it or do some other techniques to find it. So in this case, x to the 4th minus 3x cubed plus 2x, its range, you can kind of read from the graph. You can see that it looks like it hits negative 4 point something. So this is about negative 4.1 maybe. And that's the lowest value, assuming it doesn't do any weird stuff like this where it dips back down outside of our picture, assuming it just keeps going up so that it doesn't do those things. Then that's our lowest value, negative 4.1, and it's going to just go up from there. So we're going to have a range, that goes, we're going to have numbers that are above negative 4.1. And so, but that's hard to find unless you just had a graph and you can inspect it. Okay, so you might ask the questions, what happens when you add, subtract, or multiply or divide two polynomials? If you wanted to do the function operations that we defined earlier, add, subtract, multiply, composition, and so forth, what will you get? Well, if you add, you subtract, or you multiply two polynomials together, then your result, what you're going to get, is going to be another polynomial. And we can see why that is with an example in a minute. And then a couple of things to be mindful about is that what happens to the degree of these sum difference in products? Well, the sum or difference couldn't just lower the degree. It's not going to make the degree bigger. And that's kind of counterintuitive. You think, well, I'm adding two polynomials together, then my degree should get bigger, but that's not the case. It's at least the biggest degree, but it can be, it's at most, the most that the degree of the sum will be is the largest degree of the two polynomials. And then similarly for the difference, that's also counterintuitive. You think if I subtract polynomials, I'll make my degree go down. But that's not necessarily the case. A lot of times the degree will stay the same, or the degree will be at most, again, the biggest degree of the two. That's what this means. The max of the two degrees of each of those polynomials. It's going to be less than or equal to that. What about multiplying? Well, when you multiply two polynomials together, then you will get a bigger degree. And the reason for that comes down from, well, here's a simple example, x cubed times x squared. If you multiply these two polynomials, then you're going to get, and a lot of students will forget this and make this mistake, it's not x to the sixth. So this is not x to the sixth, okay? So that's no bueno. What it is in fact x to the fifth power. And the reason why it's x to the fifth power is because we're saying multiply x by itself 3 times. So we have x times x, right? That's really just breaking down what the cubing and squaring are. And so if you were to look at that and add up all the x's that you see, you've got 5 x's multiplying each other, so it's x to the fifth power. And you can see from this simple example that we took the degree of the first polynomial, 3, and the degree of the second polynomial, 2, and the degree of the product was just 3 plus 2, was the degree of the first one plus the degree of the second one. So let's look at a couple of polynomials and look at their sum, product, and sum, difference, and product, and then look at the degrees of those. So here we've got x cubed plus 3x as one polynomial, and negative x cubed plus x squared as another polynomial. We're trying to answer the question, what's the degree of the sum, difference, and product of these two polynomials? So let's add them together first. So if I want to add them together, I'm just going to, and it's usually a good idea to put parentheses when you're doing this adding. And the parentheses here should go around this part, because this is Q. That's Q. And let's get another color going here. Blue. That's P. So we got P plus Q. That's Hamlet yelling, being, annoying. Anyway, so we've got P plus Q, and we're going to add these two polynomials together. And if you are careful in observation, you'll see that you've got a positive x cubed and you've got a negative x cubed, and so these guys are going to cancel each other out, and then that's going to get you 3x plus x squared. So what would the degree of P plus Q be? Well, we had to actually add them together to find out, and the degree of P plus Q is going to be 2. So the degree, we'll just write it down here, deg P plus Q equal 2. All right, and so in fact did not get bigger. It didn't stay the same as P or Q. It actually shrunk it became a smaller degree polynomial. And that's just due to the fact that those leading terms canceled each other out and you shrunk your polynomial down. Okay, and if you subtract, now here's where the parentheses are really important. So here we're subtracting all of q, which is negative x cubed plus x squared, from the polynomial p, which is x cubed plus 3x. So we're subtracting the whole thing. So that parentheses is essential. Don't leave them out. These parentheses are super important. I'm going to highlight them really large. Because if you forget those parentheses, you're only subtracting the first term and not the whole thing. And you need to subtract the whole thing because that's what p minus q means. It means subtract q, the entirety of q, which is negative x cubed plus x squared, from p, okay? So parentheses will remind you to distribute the negative sign through. So when we do this, we get x cubed minus negative x cubed, which is going to be 2x cubed. So those two first terms are going to combine, and you're going to get this guy and this guy gets you 2x cubed. And then we have a minus x squared, because this negative sign distributed. This sign distributed to both things. We have minus x squared, and then plus 3x. And so if you were to look at the degree of p minus q, so what is that now? Degree p minus q, well, it's 3, because that's the highest power, right? The degree of the difference is actually still the degree of p or q, which is 3. And then let's do the product. So if we're going to multiply these two things together, it's very important to put parentheses around both. So I'm going to highlight that. Parentheses around p and parentheses around q, because this means multiply all of p by all of q. And so if we were to do this multiplication, we'd have to FOIL it. And so we'll just walk through each product, x cubed and negative x cubed. That's going to get you negative x to the 6th. We're going to have x cubed and x squared. That's going to get you x to the 5th. We're going to have 3x and negative x cubed. That's going to get you negative 3x to the 4th. Then we're going to have 3x and x squared, and that's going to get you plus 3x cubed. And so when you're reading this, the highest power is 6. So degree EQ 6. And if you remember and walked back, we had a degree 3 and another degree 3 polynomial, and this, you know, when you add these two degrees up, you get 6. And so that's always true. It's in fact always true when you're doing this. So you take the degree of one polynomial and the degree of the other. If you're going to multiply them together, the degree of the product is just the sum of those two degrees. Okay. Now, another term to think about with polynomials. So we've talked about the degree a bunch, and we talked about even or odd. So another feature polynomials have is that there are x values that will make the polynomial 0. Usually. If it's a quadratic and it's above or below the x-axis, for example, like this guy, we know that this doesn't cross the x-axis, and so it actually has no real zeros. There's no real numbers that will make that quadratic equal 0. But in general, polynomials can cross the x-axis, and we'll talk about so if it's an odd one, you know, an odd polynomial is definitely going to cross the x-axis, so it will have a 0. So these numbers, these x's that we're talking about, where they cross, where the value of the polynomial is 0, they're called zeros or roots. So this is kind of the definition. A number r is called a 0 or root of a polynomial, or in fact this term applies to any function, so it doesn't have to be just polynomials, if you plug that number in and you get 0 out. And then there's a link between we'll talk about this link a little bit later, but here, another important term for polynomials is that they also have factors. And a factor is can be written like this: x minus some number, x minus r, for example. And we say it's a factor if you can write the polynomial x minus r times g, where g is another polynomial. So really what you're saying is that you can kind of, and in fact, g is going to be a polynomial with degree 1 less than p, right? It's going to be a smaller degree. And what we're saying is that a factor can be pulled out from a polynomial, and then you'll have a polynomial with 1 degree less left. And you could successively do this for all of its factors till you have what's called factored the polynomial, which has broken it down into all of these x minus r things, right? And they can be x minus 2 or x plus 3 or whatever, right? So these are all the factors of a polynomial. And then here's the link between these two. And I used r for a reason in both of these. And this is because r is a 0 of p if and only if x minus r is a factor of p. So what this is saying is that a factor is a 0. Well, they're not exactly the same, but a factor tells you what the zeros are. And if you know a 0, then you in fact know a factor. So these are kind of one and the same idea. Though the techniques for finding factors, we'll be talking about those in a little bit later. Okay, so another feature of polynomials is that you're going to have at most n zeros if you've got an n degree polynomial. So for example, a cubic can have at most 3 zeros. So if it's a cubic, that's x cubed, that's the highest power plus stuff, then it's going to have at most 3 zeros, less than or equal to 3 zeros. You can't have more than 3 zeros. If you had another 0, then you would have 4 factors, 4 x minus somethings. When you multiplied all those x minus somethings together, you'd end up with a degree 4 polynomial, so that's impossible. So you have at most the number of you have at most n zeros for a degree n polynomial, and you may have less. We'll see some examples. For example, x squared plus 1, quadratic, shifted up 1, has no real zeros. So there's no numbers you can plug in to make that 0. X squared is always positive. When you add 1, you get another, x squared is never negative. It's always 0 or positive. When you add 1 to that, you're going to get something that's 1 or more, so that it's never going to be 0. Q of x equals x squared minus 1 has 2 real zeros, negative 1 and 1, because q of negative 1 equals negative 1 squared minus 1, which is equal to 1 minus 1, which is equal to 0. And similarly, if you plug 1 in, you're going to get 0 as well. So those are 2 real zeros. And if you, another approach for figuring these real zeros out is to factor q. So you factor q of x, and you get, x plus 1 times x minus 1. You can see each factor contributes one of those real zeros, negative 1 and 1. This guy is giving you the negative 1, and this guy is giving you the positive 1. And it's been factored out, and you can read those zeros from the factoring. If you were to multiply p and q together, you did the product of these two, you'd find that it also has 2 real zeros. P times q, it would be x squared plus 1 times x squared minus 1, which if you distributed it out, it would be x to the 4th minus 1. And I'll just walk through that distributing. X squared plus 1, x squared minus 1, and so you have x to the 4th, and you have negative x squared, and then you have positive x squared, and then you have negative 1. So these middle terms cancel, and you get x to the 4th minus 1. That has only 2 real zeros, -1 and 1 because x squared plus 1, that polynomial has no more zeros. So you just have the -1 and the 1 from x squared minus 1 that are giving you zeros. And so when you multiply it with q, with p, you don't get any extras. P times q is just going to still have 2 zeros. Okay, let's do an example. What are the zeros of the polynomial x cubed minus 3x squared minus 4x? And so our solution, how we're going to find these zeros, is to factor p. And we're going to factor it. This is actually going to factor like a quadratic will factor because we need to pull out a greatest common factor first. So remember, our factoring techniques start with greatest common factor if there is one. If not, then you go down to trying to guess and check the factors. And if that doesn't work, you resort to the quadratic formula or completing the square as the last. Either of those will get you your zeros at the end of the day. So we pull out an x, and that leaves us with x squared minus 3x minus 4. And then that factors down into x minus 4 times x plus 1, right? Because the two numbers that multiply to -4, whoops, that's an eraser. So the two numbers that multiply to this, -4 times 1 is going to get you -4, and -4x plus 1x, that's going to get you -3x. So from that we can read the zeros. We've got a 0 at 0, a 0 at 4, and a 0 at -1. So those would be the 3 zeros of this polynomial. And if you were to graph it, you'd find it crosses the x-axis at each of these x values. So we'd have a crossing here at -1, whoops, -1. We'd have a crossing at 0, and then we'd have a crossing at 1, 2, 3, 4, over here at 4. And you can plug in numbers and you'll find that it would do something like this. We go up, dip down below, go up, dip above, dip below, and then keep heading up after that. And you can just check by evaluating numbers and see what you get. Okay, that's the end of my slides. I'm going to go find the cat and show Mushi in a second here. Alright. So this is Hamlet. He's a very photogenic kitty. Oh no, I lost him. Alright. Sorry, I tried. Wait, maybe I can get him again. Okay. Whoa!